Hello, today we're going to talk about quantities, units, the international system of units, prefixes, etc. Okay, so physics is the science that studies the world around us, its components, the way each component interacts, etc. And for that, we need some tools. And the tools are the ones we're going to talk about today. Well, the first thing that we need in order to study the world around us is to know what a quantity is. Okay, so a quantity is any property that can be measured. Okay, any property in an object, in the world around us, etc. And that is one of the things that physics are interested in measuring quantities. Okay, so for example, we can have the length, we can have time, we can have weight, we can have intensity of light, we can have speed, etc., etc. So any property of an object that can be measured is a quantity. Okay, not all quantities are the same, and we'll talk about those in another video. Okay, in order to measure those quantities, we need units. Okay, and they used to measure quantities. I want you to understand that units are something that we have invented. So, for example, years ago, that is not so now, but years ago, a meter was a bar of some kind of material that was set up in a museum, and they decided this was a meter. And we divided that into sections, and we could have in 100, we could have centimeters. In If we divide it into 1,000, we have millimeters, etc., etc. Okay, but it's something we have invented. We could have decided this was a meter, this was a meter. Um, uh, any length could be a meter, but we decided that was a meter. Okay, the same happens with a second. The same happens with a gram. The same happens with everything. Okay, so a unit is something that we have invented. This caused a problem because a few centuries ago, nearly every town, nearly every country used different measures. Okay, so we could see it now. Some countries use meters for length. Others can also use inches. You can use gallons or liters. And then when countries started to get together, they saw that this was not useful because each one was talking about a certain quantity in different units, and we could not understand each other. Okay, so in order to clarify this a bit, countries got together and decided to create the International System of Units. Okay, the International System of Units. Why? In order to clear up this mess and decide what unit is going to be the one that we are going to use for this quantity. Okay, so they basically set up a list of the quantities and the units that are going to be measured in that, and you have to learn at least the most important ones, the most important units in the international system for each quantity. Okay, for example, I can give you certain examples, but you will have to learn more. We can have, that length. Okay, so we could have here's the quantity, and here's the unit. So for example, we could have length. Length is measured in meters. Okay, so we can have time. Time is measured in seconds. Okay, we could have temperature. Sometimes it's not so. Sometimes we in our normal life we use a unit which is not the one that the international system uses. For example, temperature. In some countries, we measure temperatures in degrees centigrade, and in sometimes in Fahrenheit. Whereas the International System of Units uses the Kelvin, okay, for the temperature. We can have, for example, force is measured in units. We could have energy is measured in joules, and etc. etc. As a whole, all the quantities that we have can be measured in has have a unit in the international system, so that we can all use the same. And someday I will talk to you about this, but this is not so stupid, because there have been cases, a very famous one from some satellite that was sent to Mars, where several countries worked together, and one of the country was measuring, and that was discovered afterwards, the length in feet, and the other one in meters. So when they were descending into the near the atmosphere of Mars, uh, the computer gave an instruction which was meant in feet, and the other part of the satellite interpreted in meters. And of course, they lost contact of the satellite, and it was destroyed. And this means years of work, and billions of euros or dollars wasted because of a problem with units. Okay, so it is very important to be able to understand the quantity and understand the unit in physics that we're talking about. Okay, so sometimes units are very big, or sometimes are they're very small. That is why in the international system they decided to use a system of prefixes. Okay, I will give you the whole list, but you will only need to know some of them. Okay, I will tell you which ones are the most important ones, and we'll see now how to use them. Okay, so for example, uh, some were created fairly recently. For example, this one, iota, zeta. I know these ones: exa, beta, theta, giga, so theta, giga, and that's a mega, kilo, hectodeca. And I will give you in our the ones who are using our online academy, I will give you this list in a PDF so you can have it. So this is here we have you have whatever unit we're talking about. So I'll say this is the unit. And then we have these are the prefixes that make the unit bigger, and then we have the ones that are make them smaller: deci, centi, milli, micro, nano, pico, femto, atto, and thepto. These two ones are new ones: thepto, and the last one, yocto. And probably they'll be adding new ones in the future. Okay, so the symbols for each one: this is a capital Y, this is a capital Z, this is an E, this is a capital P. So the ones on the top are capitals: giga, mega. Then we have until mega. Then we have lowercase for kilo, lowercase for hecto. Deca is two letters, and then we have deci, centi, and milli. You all know. Micro has the symbol. Nano has an N. Pico has an P. Femto has an F. Atto has an A. Then we have a Z again, lowercase, and then we have a lowercase y. And then we are going to know what these quantities have equate to, what's the number of a quantity, and I'll explain how to use it in a second. So I'll teach you a trick here. This is 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, and then from here on you have 10 to the power of 6, 10 to the power of 9, they go 3 by 3. 10 to the power of 12, 15, 18, 21, and 24. Okay, and the same thing happens when we're going downwards. So that's 10 to the power of minus 1, minus 2, minus 3, and then we have 10 to the power of minus 6, minus 9, pico, I'll show it here. Then we have 10 to the power of minus 12, minus, that's 3, then minus 15. I'll move this here. 10 to the power of minus 18, minus 21, and minus 24. Okay, so this is what we call the prefixes. And what are they used for? Okay, so I'll show you here so you can take a look at them. So for example, if we have 1,000 meters, that's a unit for length, but we don't want to be writing 1,000 because that has too many zeros. It's much more comfortable to change the 1,000 for the 10 to the power of 3, so that's 1 kilometer. Okay, and we can do it the other way around. If we have 1 kilometer and we want to change it into meters, we can change this for the prefix, which was 10 to the power of 3. Okay, but and this you might say, well, it doesn't make sense there. Well, but if we have, I'm just writing zeros, okay, and writing this all the time would be a mess. So then we can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the power of 9. So that's 1 gigameter, and that is easier to write than writing all the 9 zeros. Okay, the same thing happens when we have very small numbers. So if we have 0.001 meter, so we can say 1, 2, 3. Okay, so it's 1 to times 10 to the power of minus 3 meters. So that was 1 millimeter. Okay, so it's easier and we don't have to write so many zeros. The same would happen if we had 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Instead of writing 1 times 10 to the power of 9 meters, we can write, so 10 to the power of minus 9 was nano. Okay, so 369, so it's 1 nanometer. Okay, and this would you can substitute here. We've used meters, but we can substitute here any unit that you want. Okay, so 10 to the power of 12, 11, 12. I don't know. Newtons would be 1 times 10 to the power of, we said 12, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, Newton. So instead of writing that, we could just go here and say that's 1 tera Newton. And we could do that with seconds. We could do with everything. So prefixes are a way of writing in a shorter manner very big numbers or very small numbers, instead of having to write all the zeros there. And as you see, the prefixes in the international system have a decimal value. They're powers of 10. And you go upwards, you go multiplying, and downwards, you go dividing. Okay? And you can see a video that we have about how to change units with a nice method that you would never make a mistake. So, going back again, physics uses the measures quantities, which are properties in an object, in order to understand the world around us. In order to measure those quantities, we use units, and that's so in order to understand all of us and use the same units, there was in around the 1960s, the International System of Units published a list of quantities and the units that we should be using if we use this method, and most countries uses this method, and it's very important so that we can all understand what we're doing, especially when nowadays science is done with a lot of countries and scientists from other countries working together. And in order to write big numbers and small numbers, the International System of Units uses a set of prefixes, which are these ones, and which I will leave a list in the online on the in the online in the course in the online academy for you to have. Okay, so hope you liked the video.